Hello everyone, I'm teacher Mia from Kangaroo Study. Today on our road to HALP Math, Higher Ability Learners Program, a new name for GP, we're going to look at excess and shortage problem, part 4. Now, for those of you who haven't gone through part 1, 2 and 3, please do remember to go through them before going through this video. This video, we're going to talk about an even harder variation of excess and shortage that a lot of students struggle. So, let's dive right in. First, let's read the question. Eric is doing a set of exercises within a time limit. If he does one question every 2 minutes, he will have 3 questions left at the end of the time limit. If he does 2 questions every 3 minutes, Eric can finish the exercises 3 minutes earlier than the time limit. So how many questions are there in total in the set of exercises? So, every time when we do excess and shortage, what do? We always draw. At first, when we are distributing books to teachers, we draw how many teachers. Then we distribute how many books to each teacher. Then, when we move on to rooms, we're distributing students to rooms. So, we draw rooms. Then, how many students we have for each room. For this case, what should we draw? Now, you see, here, we are doing 1 question every 2 minutes. 2 questions every 3 minutes. Now, what do we distribute? You see, previously, we distribute books to teachers. So, we draw teachers. Because one teacher will have a lot of books. And one room will have many students. So we distribute students to teach 2 rooms. But now, what should we distribute to? We have question and time. So which one to which? Now, we can do it this way. Here, we have 1 question every 2 minutes. Which means that every 2 minutes, there is 1 question. So we actually can distribute questions to time. So it's easier for us to do. So every 2 minutes, 1 question. Every 2 minutes, 1 question. Then, similarly, for the second case, every 3 minutes, there's 2 questions. So every 3 minutes, there's 2 questions. Every 3 minutes, 2 questions, 2 questions, 2 questions. Okay? Then, one thing that we need to understand is that for the whole set of exercises, when Eric is doing, the time limit, does it change for the both cases? No, it doesn't. So it's the same. So we can use a big rectangle here to show the time limit, and the same for case 2. Both of them are the same. Then for case 1, 1 question every 2 minutes. So let's have 2 minutes here. Then for every 2 minutes, 1 question. So this is 1 time period of 2 minutes. And we will have this time period as well. And we will have many more time periods of 2 minutes. And every time period, we have 1 question. Then similarly, for case 2, 3 minutes, every 3 minutes, we have 2 questions. So we have every 3 minutes, 2 questions. Every 3 minutes, 2 questions. Every 3 minutes, 2 questions, and so on. And then, for case 1, we see that at the end, you have 3 questions left. So we will write 3 questions left here. Now, what about case 2? We see that if he does 2 questions every 3 minutes, Eric can finish the exercises 3 minutes earlier. So, you see here for case 1, we are talking about 3 questions left. But in case 2, 3 minutes earlier. 3 minutes. But we are talking about questions. Can we convert these 3 minutes into questions somehow? Yes, I'm sure some of you have noticed. Yes, Eric does 2 questions every 3 minutes. So this means that these 3 minutes can convert to 2 questions. Very nice. But now these 2 questions, is it 2 questions left or 2 questions needed? Now we see that Eric finished the exercises earlier. So that is not that he still have questions left, but earlier. So he needs 2 questions in order to finish exactly at this time. So it is 2 questions needed. So we write 2 questions needed. Now, let's look here. How do we solve them? Now we know that this is left needed. All we need to do is just plus. And then we minus. But now the question is, 2 minutes. You see here, we are distributing the number of parts. Last time we talked about we're distributing 1 question to number of parts, which is time here. But then the number of parts, the parts here is different. You see here we're distributing 1 question to 2 minutes. 1 question to 2 minutes. But here we're distributing 2 questions to 3 minutes. Oh, that's weird. Now, let's look at an example here. It's just like, here I tell you that, okay, I give every student 5 candies and I have 15 candies left. Then, at the second case, normally what we will have is, for example, I give 1 student 7 candies, and every student 7 candies, and I need 10 candies left, for example. But this time, the question don't tell you that. The question gives you another thing. The question tells you, I give 2 students 15 candies. I need 2 students, 15 candies, and so on, and I need 10. Then, now, isn't that weird? You see here, always from all our previous questions, we always distribute to the same number of parts. I distribute to one teacher, one teacher, one teacher. It's just that case 1 and case 2, every teacher receives different number of books. But here, I'm distributing to one student and two students here. So how should we do? Can we even do this? I don't think so. No, but if, here, if we are talking about one, if you are giving one student and giving one student, or one student here, do we know how to do? We know. What if here is two students, and here two students? Do we know how to do? We also know how to do. So, what should we do then? This means that we should change to make them the same. So let's try. There's two ways to change them, right? We can either change this single into 2, or we can change this 2 into single. Let's try if we can change this 2 into single. If we change this 2 into single, 2 students get 15. So 1 student should have, 15 cannot divide by 2. This means that we can't change these 2 students into 1. I can only change 1 into 2. So how should I change this 1 into 2? Let's say I change this 1 into 2. Then 1 student eat 5 candy, 2 students eat 10. So 2 students eat 10. We can change them like this. And it will be the same 15 candies left. At the start, when I give 1 student 5 candies, I will say 15 candies left. It's just that now, I tell you that instead of 1 student 5 candies, 2 students get 10 candies. Okay? Then, in the end, there still be 15 candies left. Then how to solve this? Very nice. Very nice. Just 15 plus 10. And then divided by 15 minus 10. Perfect. Then we get 5. Now, what is this 5 here? Is it 5 students? So let's see from the definition. Here, after I give everyone 10, I say 15 left. Oh, let me give more. Then I give everyone 15. I give each group of 2 students 15 candies. Then, I still need 10. Is this 15 enough? Not enough. I still need 10. So what is the extra? What is the total of the extra candies that I gave to 2 groups of students? 25. Yes, 25. Then, the extra candies received by each group of 2 students is 5. And if I take these two things, I divide them, what I get should be the number of groups of 2 students. Since all we are talking about is these 2 students. So what we get here is actually 5 groups of 2 students. So how should I find the number of students? Very nice. Yes, it's 10. How do we get? 5 times 2. Easy. Now, how to find the number of candies then? Now, to find the number of candies, best way here is to just take as groups. Because we know how many groups here. We know that we have 5 groups. Every group has 10 candies. So, all we need to do is just 5 times 10 and plus 15. Or 5 times 15. What do we should do with this needed? Minus 10. Perfect. So, that's all. So, let's do a very quick summary here. Now, if the number of parts is different, just now we give 1 single student, but here we give 2. We need to change to make them all the same. Then, when calculating, remember, this 5 here is not 1 student, but it's groups of students. It's basically what we draw here, okay? So now let's move on here. Now, we know that these 2 minutes, 3 minutes, they're different. So, let's try to change these 2 minutes. Now, one thing that we can change these 2 to 3. But can we change 2 minutes into 3 minutes? I mean, I can change 2 minutes into 4 minutes. I can change 2 minutes into 6 minutes. But can I change 2 minutes into 3 minutes? I know that if I change to 4 minutes, how many questions? 2. I change to 6, how many questions? 3. But if I change to 3 minutes, how many questions do I have? That is very hard to calculate, right? So, I don't think we can change 2 minutes to 3. Similarly, we can't change 3 minutes to 2. So, this means that we need to change into a new time period where both 2 minutes and 3 minutes can change to. So, what time period should we change to? Very nice. I'm sure some of you have got it. This means that we need to change 2 minutes into that time minutes. So it has to be a multiple of 2. Similarly, 3 minutes have to change as well. So it must be also a multiple of 3. So the smallest multiple of 2 and 3 will be 6. Very good. So let's change it into 6 minutes. Now here we know that, 6 minutes. Then we know that it is 3 questions just now, like just now what we said. Then let's put a stopwatch here as a symbol of this time period. Then we'll have many time periods. Next, let's try to convert this. Now, 3 minutes, we have 2 questions. 6 minutes, how many questions? 4. Perfect. Then we will have like this and continue on many time periods. And this part will never change, okay? So, how do we solve it? Very nice. 3 plus 2. And what about the change? 4 minus 3. Perfect. Then we will get 5 divided by 1. We get 5. Now, what is this 5? Just now, what did we say? We said this 5, what we get is what we draw here. So here what we draw is this stopwatch. So we get 5 stopwatches. What does one stopwatch mean? One stopwatch means 6 minutes. So we get 6 minutes. So it's 5 groups of 6 minutes. So what is the total time limit here? Very nice. Just 5 times 6 is 30. Perfect. Now let's answer the question. The question says, how many questions are there in total? So just now when we said that, we don't use this 30 minutes. We use groups. We know that we have 5 stopwatch. So one stopwatch is 3 questions. So 5 stopwatch, how many questions? 5 times 3 and plus 3. Perfect. So we get 5 times 3 plus 3 equals 18 minutes. 18 questions. Or here we have 6 minutes. We have 5 stopwatches with 4 questions each. So 5 times 4 and here minus 2. Perfect. So it's the same. 18 questions. So perfect. Now let's do a very quick summary here. So this is the excess and shortage problem. Now if we see the number of parts are different in both cases, what should we do? Yes, we should change it to make it the same. Very nice. And second thing, we should be careful when we are calculating. Remember, what we get is what we draw there. So it can be easier for you if you draw stopwatches to represent, for example, 2 students. You draw a group. You draw 1 circle to represent these 2 students. Then what we get is this, how many circles do we have? Okay, then this circle represents 2 students. So it's better for you to understand. And now here we have some practice questions for you to do. Then, now, feel free to try it and type it down in the comment section down below. And if you have any questions, feel free to contact me here at this QR code. I will answer you. So don't be shy, okay? Just ask me any questions. Then feel free to join our 2026 Future Study Group as well. We will give a lot of worksheets as well as activities, open classes, okay? So, I'm Teacher Ming Wei, signing off. Goodbye everyone, see you on our next video.